In previous sections, I showed you how you can use network and redistribute commands to add prefixes to BGP database and advertise them to other autonomous systems. Now I want to show you something that is so important. As you know, router 4 receives all the prefixes from ISP1, and this is what we meant to do that. If I go to router 4, I can see that router 4 has some advertisement, and actually it will advertise those routes that has been received to other routers such as router 2. But if I go to router 2 and check these, I can see that router 2 has received these routes, and they are installed in their BGP in their routing table, and they are marked as internal BGP. And here the problem arises. When we have internal BGP routes, the rule says that we do not advertise internal BGP routes to other internal BGP neighbors. So we do not expect router 1 to receive these routes. And again, if I go to advertisement, I can see that I'm not advertising these routes to other BGP neighbors, because router 4 is my iBGP neighbor, router 1 is my iBGP neighbor, and I cannot send these routes to router 1. So what if router 1 wants to reach to ISP1's prefixes? So if I go to router 1 and try to see the routes, actually I have no routes here to ISP. So if I try to ping, actually it is gonna be a failure. So if I try to ping 100, 100, 11, 100 and start the ping, you can see that it tells me there is no route to the destination. So I stop and close this. And I want to show you different approaches to solving this problem. One of the best, and of course, not the best, one of the worst solutions, and the oldest solution actually, is to redistribute the BGP routes into IGP routing protocol. And I can do this based on router 4. If I go to router 4 and go to BGP instance, go to actually to OSPF instance here, I can select the instance and double click on that, and as you can see, I have a redistribute BGP routes here that is by default no. So if I try to select it, for example, as type 1 and click on OK, you can see that the problem solves easily. If I go to router 1, after a moment I can see these routes here, and they are advertised by OSPF, and here they are. Now if I try to ping one more time, the ping is going to timeout, and this is because the other end, that is ISP1, does not have any route back to me. And I'm going to solve this easier. I can go and add some static routes to ISP1. I can go to router 4 and redistribute OSPF into BGP so that ISP1 can receive these routes. And let me do this on router 4. If I go to router 4, and of course this is a very fast solution, I should not do this, but I am doing this just to show you how you can do this. Go to instance and try to redistribute OSPF, and actually redistribute connected routes as well, and try to do this. If I go to ISP1, now ISP1 receives all those routes in my network. If I try to see IP routing table, you can see that it knows about my network completely. It has received all of them via BGP. Now if I go to router 1 and try to ping again, you can see that the ping is going to be successful. So this is what I have done right now for the beginning. And if I go to other routers, I can see all of those routes in other BGP neighbors, such as router 3. So let's go back to router 2. Let's check to see if router 2 has the routes here with OSPF and with BGP. As you can see, router 2 knows these routes and they are not active any longer because we have the same routes with better distance, that is 110 for OSPF. So we are not going to use these BGP routes any longer. So why should I do this, and what would I do for this problem with these inactive routes? In some platforms such as Cisco, we have a kind of setting in BGP distance. If I go to routing, I can now go to BGP and select the instance. As you can see on MikroTik, this is not supported. There is a setting called synchronization, and if you select synchronization, synchronization will go and add the routes to BGP table if that route is already in IGP and it is a best route. And as you can see, I have such thing here. I can go and add it to my BGP table, and actually I'm not going to use that. I will only have it in my BGP table. But here, this is in BGP table actually, and it is in routing table, but it is inactive. So this is not a good solution to use redistribution to add routes into my IGP. If you go to big ISPs, or if you go to, for example, a big organization, you can see that in this enterprise, if I try to import more than 300,000 routes into my IGP routing table, it is nonsense. It is, it doesn't make any sense. So I will not go for this solution, and I will remove the redistribution. I don't want to have redistribution. What I am going to do is to add another kind of configuration that is called route reflection. And for route reflection, I need to change the type of neighborship I have created here. And I want to show you how you can do this in next section. So let's go and remove the redistribution from router 4. If I go to BGP, I can remove the redistribution from here. I can go to router OSPF, and under this, double click on instance and select to remove the BGP redistribution and click on OK. And in next section, I want to enable route reflection to show you the best and the newest solution for this problem.